Now, a third type of probability has to do with angles in a circle graph. It's not very complicated. You probably did this in middle school, so I'm going to go over this kind of quick. I want to find the probability of spinning a spinner and having it land on purple. So I'm going to look at my angle. My sample space, since it's a circle, is 360 degrees. And the probability of landing on purple, or the angle, would be 30 degrees. And that reduces to 1/12. And if I write that as a decimal number, if I just do 1/12, that's 0.083. Or 8.3%. Now if we look, and that's for the probability of landing on purple. Now let's do the probability of landing on green. Same thing. My sample space is still 360 degrees. And then the green is 125 degrees. If I reduce 125 to 360, that's kind of an ugly fraction. We don't usually describe decimals as 25. Our probability is 25 over 3072, so we're going to say just 0.347. So that's 0.347 or 34.7%. Now if we look at example 7, here's an application that doesn't seem like we can figure it out. But if we represent it as area, I think we can. It says Kyler is visiting the museum and wants to take a guided tour. A friend suggests that he do the tour with DeMarcus rather than Cody because DeMarcus's tour was more informative. Tours with DeMarcus depart every 45 minutes, while tours with Cody departs every 30 minutes. That kind of makes sense because DeMarcus is more detailed. His is going to take longer. And I want to know the probability, first of all, what's the probability that Kyler will have to wait 20 minutes or less for each guided tour? So what I'm going to do is I'm going to represent this with an area model. DeMarcus, his tours take 45 minutes. So we're going to say that. And so here's 45 on my tour. Cody, his tours take 30 minutes. Let's label that so we understand what's going on. Now I'm going to start with my first question here. My first question is, what's the probability that Kyler will have to wait 20 minutes or less for the guided tour? Now, 20 minutes for DeMarcus, I'll put that right here. Here's my 20. Here's my 20 for Cody. So I can represent that as a rectangle. So in other words, it's an area model. What I'm going to do is I'm going to find the probability that'll be in this rectangle out of the big rectangle. We'll start here. My sample space is going to be the area of my whole rectangle. Well, that's going to be 45 times 30, isn't it? So 45 times 30, that's 1350. Now, the probability we have to wait less than 20 minutes, or my favorable outcome for less than 20 minutes, I'll represent that. I don't want to write less than, I'll say less than 20 minutes. And then that would be 20 times 20 would be 400. So the probability that we have to wait less than 20 minutes for a tour, doesn't matter who it is, that would be 400 out of 1350. And that's about 30% then, isn't it? Let's see if I represent 400 out of 1350 as a fraction, if that turns out to be a nice whole number, or a fraction we're used to seeing at least. If I could type that in, the problem would take less longer. And that is 8 out, yeah, let's leave it at 30%. Okay, it's actually 29.6%, 0.296 we'll say. But rounds to 30%. Now, how about the second part? What happens if he waits less than 20 minutes for one tour? Well, it doesn't say DeMarcus or Cody, so we're going to have to do this twice. So let's look at DeMarcus. Well, less than 20 minutes for DeMarcus. I'm going to fill this in a little bit. So that would be this rectangle here, wouldn't it? So I'm going to take 20 times 30, and that would be 600. Now let's do Cody. Cody would be less than 20 minutes. We'll have to go, whoops, I wanted my highlighter there. So that will be 20 times 45 then, wouldn't it? That'll be that rectangle. So Cody is going to be 20 times 45, which is 900. But notice I've double counted that green rectangle, haven't I? So I shouldn't count that twice. I should only count it once, because I counted it for DeMarcus and for Cody. So what I'm going to do is I'm going to subtract off the 400. So my favorable outcome is going to be the area of my pink rectangle, which I said is 900. The area of my yellow triangle, which is 600. But I included the green triangle twice, so I'm going to subtract off the area of the green triangle, which is 400. So when I do that, I will get 1,100, won't I? So then we'll take 1,100 divided by 1350. Rewrite that 1350 for us so it's easier to see. And 1,100 divided by 1350 is going to be, let's keep it as a decimal, 0.815. Which, make sure I've rounded right. Yeah, 0.815. So it'd be about 81.5%. So if you show up for a tour, you don't care who you see, you got a pretty good probability you won't have to wait very long, as long as we do one of those.